Hey y'all, welcome to my talk. My name is Margarita Medina. I'm a senior chaos engineer at Gremlin. Today we're going to be talking about import chaos. How do we make our Go applications more reliable as we keep in mind that we're going to be scaling them out to our customers? So prior to getting started on today's talk, let's start by setting the tone. It's a tough fact to face, but as we know it, the software is going to break. Failure is inevitable, and the world that we're building continues to rely on this technology that's very brittle. How is it that we can continue innovating and delivering and shipping our products while keeping in mind minimizing the risk of failure and making sure that our customers and users have a great experience? You might be thinking to yourselves, no, there's no way that the application that I'm building is going to fail. And you realize that it fails when you do get paged at 4 in the morning, 3 in the morning, or someone else in the organization is on call for the service and they ping you because they're having a hard time debugging what are the issues that could be having. So for some of you in the room that's having some issues thinking about ways that their applications can fail or anything like that, some questions that I start off today with is, what happens if we lose connection to our network? Whether you're working on a backend service, a web application, a mobile application, when that connection get lost, how is it that this application handles it? Whether it's a momentary loss of connection just for a few seconds, or it's a complete disconnect from the network. What happens if one of your upstreams or downstream dependencies stops working? Whether it is that they hit their limit of requests, whether their servers are maximized, or maybe it's a third-party dependency and that service is currently having an outage. And in that scenario, what actually happens if those calls are actually just having a little bit more latency? Can your application just wait that 1 second, 500 milliseconds to wait for that response to then synchronously continue doing what your application does? Those are things that we have to constantly ask ourselves as we're building these applications in this distributed computing space. And when we're thinking about scaling them out, these things continue adding more complexity. Another question that you can ask yourselves is, how many concurrent sessions can I have before my servers maximize out on the resources that they can provide? Whether that is a disk limit, an IO limit, a CPU, a memory, anything like that. We have to keep in mind that yes, we now have a lot of cloud that's backing up all of our distributed systems, but if we're not constantly making sure that we're scaling them out or our applications are able to handle that auto scaling that our mental models think they do, we are just having these ideas in our mind. How is it that you can know that your systems are going to handle failure when it scales? Or is it going to be a cascading failure that happens once and then it starts replicating across all of the instances of your application? You might feel like this GIF here where that failure just exponentially gets larger and you're like, oh, I don't know what to do now. Well, how is it that we can get ahead of that? And what is this catchy title that I put for today's talk of import chaos? Well, today I'm going to be talking about chaos engineering. And to talk about chaos engineering, many of you may have not heard of this term before. So I wanted to start off by introducing the term of chaos engineering. Chaos engineering is the science of performing intentional experimentation on a system by injecting precise and measured amounts of harm to observe how your system responds to it. And the purpose of doing this is that we want to improve the system's resilience. If this definition is a little too much for you, the company that I work for came up with this simple definition for chaos engineering. Chaos engineering is thoughtful, planned experiments designed to reveal weaknesses in our systems. Chaos engineering is not about breaking production, is not about just breaking our systems without telling our teammates or anything like it. It's not about just trying to make sure that someone knows how to wake up to that page or anything like it. Chaos engineering has a science behind it. We do this very thoughtfully and planned, and you don't start by just doing chaos engineering in production. You want to start off with small experiments. And we're going to dive into what all of this means. But first, I wanted to introduce myself. I mentioned earlier, my name's Ana Margarita Medina. I am a senior chaos engineer at Gremlin. I've been writing code for many years. I got started in just building front-end websites, later transitioned to some more back-end stuff with Python and JavaScript, eventually found my way into building mobile applications on iOS and Android, and later on I became a site reliability engineer and specifically started focusing on chaos engineering. That's actually when I started writing more Go code. And one of the other things I love mentioning when I'm here up on stage, even if it means virtual, is that I'm a proud Latina. I love carrying my flags with pride. I was born and raised in Costa Rica. My parents are from Nicaragua. So representation matters. Gotta make sure to always mention that. To continue talking about chaos engineering, first I wanted to define some other terminology that I started touching upon with the definition of chaos engineering. First, chaos engineering is about experimentation. We go back and we think about the scientific method that we learned in primary school, elementary school, and we bring that to the front. We're going to experiment in our systems. That means that we're gonna come up with a hypothesis. If X happens to my system, I expect Y. And some of the other terminology that's very specific to chaos engineering is the term of blast radius. How large is this chaos engineering experiment that I'm about to start is? With that, we also have magnitude. That is the impact or the intensity of the experiment that you're about to unleash. And one of the other most important terms with chaos engineering is abort conditions. Those are those conditions that would cause you to stop your experiment, whether it is your latency spiking up, the traffic rate going up, increase of error rates, anything that lets you know that your systems are not handling this failure properly. So to start out with visually understanding what the magnitude of a chaos engineering experiment is, we have it right here where our first test is going to start small. And as we build the confidence in these experiments, we can slowly start increasing them. And this goes with our environments too. I know a lot of folks get turned off by the term chaos engineering. I don't want to do chaos engineering in production. And one of the things that we say is that you start off by implementing chaos engineering in all of your environments prior to productions, to staging, dev, QA, testing, whatever those the environments are, you start experimenting there. As you build a confidence, you start introducing chaos into production. So that brings us to how is it that I put the scientific method and these terms that you're talking about together to do chaos engineering, Anna? Well, first, we start by observing our system. This means pulling up the architecture diagrams, looking at any dashboards or metrics that you have coming in for these services. You also kind of want to baseline what your system looks like under normal conditions. Whether this is looking at your service level objectives, service level indicators, understanding the KPIs that this provides to the business. Now you can start forming a hypothesis. You want to be thoughtful about this process and you want to make sure to write this down so that you're taking good notes as you go through your entire experiment. As you come up with a hypothesis, one of the most important things is that you can't forget to come up with abort conditions. As I mentioned, abort conditions are those conditions that are going to cause for you to halt an experiment. Then you go ahead and you define that blast radius and magnitude and you start running that experiment. As that experiment runs, if an abort condition is hit, go ahead and stop that experiment. Go make your application more resilient and then execute the experiment once again. And you do that as you continue growing your experiment. So after you run that experiment, you want to make sure to analyze those results, go ahead and expand that blast radius, increase that magnitude. And lastly, as you're building confidence and learning with doing these experiments, you want to go ahead and share the results. This goes back to the scientific method. We all learn together, whether that is sharing with your organization things that you have found of the Go applications in your systems, or that could be giving a talk in the open source conferences or any of the programming languages conferences around some of the systems that you're running at scale as you're injecting failure into them. You want to be proactively and constantly be testing for these scenarios. At the end of the day, we're building distributed systems that are really complex, and there are things that we must constantly test for. If we don't test for them, we will suffer from an outage. So to be proactive about it, I wanted to leave you with some examples of chaos engineering experiments that you can start running on your application. One of the hello world type of experiments that I always love talking about, whether I'm talking to infrastructure engineers or engineers that are Go engineers and just building applications, maybe that might be web applications, or those can be all the backends for our systems. You want to make sure that you're setting up your monitoring properly, whether that's a monitoring tool, an observability tool. The last thing that you want is to be working on these systems, being on call for them without having a full understanding of things that can go wrong. So after you set up that dashboard, one of the things that I've told a lot of the customers that I've worked with is just go ahead and run a CPU experiment. Make sure that your monitoring has been set up properly. Maybe you're also making sure that you're linking to the proper runbooks, that your runbooks actually are linking to the proper dashboards, and so forth. So with this one, you can start off by just choosing maybe 60% of the hosts that this application is running on and increasing CPU just by 50%. Your abort condition would be that your application is not responsive, or maybe it's not showing up on monitoring. The abort conditions very much depend on the systems that you are running with. And for this one, the hypothesis that I'm going to write is that when I inject CPU into my system, I expect to see it in my monitoring dashboard. And if that wasn't the case, then I want to make sure to constantly go back and improve upon it. The other chaos engineering example that I wanted to leave you all with is really, really important to building distributed systems, microservices applications. I mentioned that I wrote Go as I was a site reliability engineer. I was working on Uber's internal tooling for infrastructure, and one of the applications that we were building out was how do you make Uber go from a bare metal data center type of workspace to something that's leveraging the cloud. But how do you do it in a way that you're not vendor lock-in? As we were building this, we kind of had to keep in mind what happens if the GCP or AWS providers are not available. How is it that we handle those errors? So yes, we do a lot of testing in the Go community, and we make sure that we have all that set up. But sometimes those errors are not necessarily errors that we always encapsulate in code as we're building them out. So one of the ones that you can actually do is that you can start by throwing a little bit of latency inside your functions and try to understand how the rest of your application handles that failure, whether it's proper error handling, whether it's having the proper timeouts. So by just starting a chaos engineering experiment on one service, just go ahead and ask yourself, what happens if this function takes 500 milliseconds extra to run than on a normal day? What happens if that's 700 milliseconds, 1,000 milliseconds? Sometimes we start seeing that there's a lot of race conditions. There's maybe a lot of other dependencies that you're not really seeing reflected on the architecture diagram or on the mental model that you have built for your system. So for this one, we're doing that latency experiment, one service, a magnitude of 500 milliseconds of latency increase on these functions, and the abort condition is going to be that the application is unable to handle any latency, and my other abort condition is if the application is crashing or traffic is completely dropping off because I am running this on production. So my hypothesis is going to be that when my application sees latency with its dependencies, it's still able to provide a resilient user experience. And I make my hypothesis include that user experience because at the end of the day, that is one of the beautiful things that we get to validate with chaos engineering is that we always want to make sure that we could see that our services are up in our metrics or anything like that, but we also want to go back and say what is that the user needs to be doing right now, whether they're going through e-commerce website, a financial application, or anything like it. We want to make sure they keep in mind what is it that the user is trying to do. So those are 2 easy chaos engineering experiments that I kind of wanted to leave you after today's conference to make sure to kind of like grasp how is it that I'm actually currently observing my applications, and I make sure that what I'm observing it with actually knows how to handle some of that failure. And then of course, when we inject failure into the network layer, how is it that our entire application as a whole is able to continue providing a reliable user experience for our users? And then sometimes things are going to fail. You can't avoid failure, and you're gonna get paged, but you can use that as a learning opportunity. Your company has already invested in an outage, so that is really expensive lesson. How is it that we can continue learning more from this? Well, you can look at those past outages as learning opportunities. You can go ahead and make your systems more resilient after you have gone through that outage and the postmortem and such. And then you can go ahead and you can recreate your past incidents to not drift into failure. I think that's one of the things as engineers that we always never want. We've already suffered this failure. We want to make our systems better and not get paid for the same thing. But sometimes we forget that, yeah, all the Jira tickets closed, but nobody's going back to validate that if these outage conditions were to happen to my system again, can my system actually withstand those failures? Once again, we want to be proactive and constantly be testing and making sure that all of our downstream and upstream teams are also doing the same. These are really complex systems, and because they're so distributed, the failures can continue cascading. So we want to make sure to be testing for those edge cases to be able to stay up. And at the end of the day, failure is going to happen. So it's all about your team responding to it and learning from it. And as you do more chaos engineering in your organization, you'll see some other increases when it comes down to that. You might see the amount of incidents start slowly going down. Maybe your team is just able to detect them quicker, or maybe it's that they're actually able to resolve them just a tiny bit faster because they're used to some of these failures. And you want to make sure to run chaos engineering experiments on everything, whether that's the back-end applications, your front-end applications, your monitoring tooling, your CI/CD, or anything like that. Just go ahead and test it. And there's also some great talks around how do you do chaos engineering in our people systems, whether that is just putting someone in your team out of office for a day, someone taking an hour extra to respond. Dave Renzen, who does Google's SRE, has put out a talk on this. Make sure to look into it if you're actually curious on learning more about doing chaos engineering in people systems. With that, I would like to thank you all for coming to my talk on import chaos. We would like to also offer you some stickers for the chaos engineering community. This community is over 6,000 folks across the globe, and there's these really cool stickers that I constantly love. So if you want to get a free sticker sheet, head on over to gremlin.com/talk/Anna-Go Systems Conf. And with that, I would like to say thank you very much for coming to my talk today. Thank you, Go Systems Conf, for having me. I hope you all were able to learn something around chaos engineering and scaling your Go systems reliable. If you have any questions around this topic, feel free to reach out via email. I can be reached at anna@gremlin.com. And if you're on Twitter, I'm Anna_M_Medina. I'm around to chat around chaos engineering, building reliable systems, mental health, and diversity in tech. And if you're interested in getting started with chaos engineering in a very simple way, head on over to go.gremlin.com/Anna to give Gremlin free a spin. Thank you all. Gracias. Have a great one.